Assalamu alaikum. As you see, so the lesson today is about system of equations. We are going to learn how to solve a 2 by 2 system of equations using substitution method. So the idea behind substitution method is to exchange one of the equations, which is two variable equations, into linear equations with one variable. That's the idea behind substitution. But before we start learning how to use substitution to solve the system of 2 by 2, first let's define what is substitution. Get an idea what is it. So the definition of substitution is a process of exchanging an expression by another equivalent expression. So the two expressions, they can be different, but they have the same value. That means they are equal in terms of value. So this is exactly what is substitution. So substitution is a process of exchanging an expression keep in mind that variable is an expression by another equivalent expression. It can be a number or it can be an expression. A number is a numerical expression. So that's the definition of substitution. So now let's start learning how to solve a 2 by 2 system using substitution method. So first let's give a system of equations. So we have ax plus by equals c, a1x plus b1y equal c1. So this is a 2 by 2 system. So we have two equations with two variables. So the first equations is linear equations with two variables. The second equation is a linear equations with two variables. So the idea of the substitution here is to exchange one of those equations from linear equations with two variable into linear equations with one variable, which is easy for us to solve because this is what we learned previously, that we can solve linear equations with one variable. So that's the idea behind. So let's see how we apply the idea. First, we need to pick one of the equations. Either we pick the first one or we pick the second one. It doesn't matter which one, but always pick the easy one that gives you an easy variable. So that's the idea. So for example, let's pick the first one. We can pick the second one. It doesn't matter. It's the same thing. So but we need to pick one of them. So I pick, for example, the first one. So I have ax plus by equals c. So either I solve for x or I solve for y. Again, it doesn't matter which one you solve for. The idea, it will end up with the same solution. Either you start solving for x or solving for y. So this is your choice. Choose what you see is easy for you. Either you start with x or start with y. So that's your choice. So let's suppose I want to solve for x. So I'm going to minus by both sides. Then I divide by a. So I got my x is c over a minus b over a y. So that's the first variable, but that variable depends on y. So what we do now, because I picked the first one, now what I do, I pick the second equations. So this is my second equation. And as you see, this x that we solved for at the beginning is the same thing as that x. And this x has another value. That means you see we have equal here. That means that expression is equivalent to that x. You see that expression is equivalent to that x. What I do, I'm going to exchange that x by this equivalent expression. Did you see the definition of substitution? This is exactly what we're doing now. I'm going to exchange that x with its equivalent expression. You see they are equal. That means this expression is equal to that expression. Even if it's one variable, it's still an algebraic expression, is an expression. So x is equal to that expression. So I substitute this x by that new expression, which means I exchange the letter x by this new expression. But keep in mind, this is an expression with two terms, not one term. So which means when I exchange x, I need to create parentheses. So here, this will become c over a minus b over a y. So let me use a light color. So yellow will be better. So here, so I will exchange x by c over a minus b over a y. But like I told you, this is a two-term expression, so we are going to do parentheses here and put my a1 here and b1 y equal c. As you see here, how many variables we have here? We have only one variable, which is y, and this type of equations is a multiple-steps linear equation with one variable. This is a multiple-steps linear equation with one variable, and you already know how to solve a multiple-steps linear equations with one variable. So the steps are the following: you distribute if you need it. In our case, we need to distribute here. The second, what we do, we combine like terms. We change from multiple steps to two steps in the equations. Then we solve for the variable using the reverse order of operation, which is PEMDAS. So you change it to SUMDIP. So this is exactly what you are going to use here. So if you want to have more depth information about how to solve linear equations, you can use my, or you can watch my video about how to solve a linear equations. Now, first I distribute. So I got a1c over a minus a1b over a y plus b1 y equal c. Now, what I do, I combine like terms. I'm going to move that number here, so which means I will subtract minus a1 c over a both sides, which give me here minus a1 b over a y plus b1 y equal c minus a1 c over a. So my second step now is I combine like terms, those two. So here we have a1 b a y and we have b1 y. So what we do, we combine coefficient of the variable y. So we are going to the coefficient of the variable y, which means we will get this idea. So we will get y times its coefficient, which is b minus b a1a equal c minus a1c over a. Now we combine, we make same denominator, so we need to subtract those two and those two. That means we're going to make common denominator, so we'll end up having y times ba minus ba1 over a, and the same thing here, ca minus c1a minus a1c over a. Now we're solving for y, so we divide both sides by ba minus ba1 over a. So here there is, oh, here this is b1, sorry. So b1a minus a1 over a. So we cancel a here because both of them are in the same location, both of them are on the denominator. Or you can use this idea. So when we divide fraction by fraction, you multiply the denominator by the reciprocal. So a1 times a over b1a minus ba1. So we multiply the denominator by the reciprocal of the denominator. So here we cancel the a and we end up having at the end y because those cancel out. So it's going to be c1a minus a1c over b1a minus ba1. And as you see, we already find out the y. And by the way, if you don't know how to simplify fraction, divide by fraction, you can use the idea because this is most easier than that way. And after we find out y, what we do, we substitute y into the expression of x. Remember, x we find out is x equal c over a minus ba y. So what I do, I substitute this y again by its new expression. So x will be equal c over a minus b over a times the new expression of y, which is c1a minus a1c over b1a minus ba1. So now we have the true value of x and the true value of y. So we're done, and we can write down our solution using the pair xy. So that's the big idea behind substitution. So let's do an example and apply what we learned. So let's do an example. For example, I want to solve the system of equations. So solve 8x plus 8y equal minus 8 and 3x plus 6y equal minus 3. So first, before I solve my system, let me use the Isel test and check what type of solution I have before I start solving the system. Do I go ahead or I can stop right away and I conclude? So let me check. So let me do the Isel test. So the Isel test is I take the coefficient of x and I make a ratio of them. So it's going to be 8 over 3. And the coefficient of y is 8 over 6. And as you see, they are not equal at all. So this is a consistent and dependent system. So this means there is a unique solution. I can go and solve for the solution, and I'm sure I will find out a solution. So this is consistent and dependent system. So now what I do, I'm going to pick one of the equations. I have the first equations, I have the second equations. Which one I pick first? You see, the first one is easy. Why? Because it has a common factor. I can simplify and I can get x easily or y easily. So I pick the first one. Like I told you earlier, always pick the easy equations. You can pick the first one or the second one. It does not matter. It's up to you. So before I keep going, what I do, I'm going to simplify. Always, if you can simplify in equations, simplify it first. More you simplify it, more it's easy for you. So here I divide both sides by 8. So I will end up having x plus y equal minus 1. Now, either I solve for x or solve for y is your choice. You see, you can solve for x or solve for y. I will solve for y, so I'm going to minus x both sides. So I get my y equal minus 1 minus x. I can solve for x if I want. Now, what I'll do, I pick the second equation. I have 3x plus 6y equal minus 3. So what I do, like I told you before, this y has an equivalent expression which is minus 1 minus x. So what I do, I substitute this y by its new equivalent expression minus 1 minus x. And this is two terms expression, so which means I will create a parenthesis here. So it's going to be 6 times minus 1 minus x. If you don't create a parenthesis, you will end up having 6 minus 1 minus x, and you're going to get confused. You're going to, instead to multiply 6 by minus 1 and 6 by minus x, you're going to subtract and you're going to get the wrong answer at the end. So be careful. Now this is equal minus 3, so I distribute. So now I have a multiple steps linear equations with one variable. I distribute, combine like terms, and solve for the variable using the process of how to solve two-step linear equations. So this is 3x minus 6x equal minus 3. Combine like terms. So I got minus 3x minus 6 equal minus 3. Then I add 6 both sides. Minus 3x equal 3 divided by minus 3. So x will be equal minus 1. Now I'm gonna substitute this x into the y expression, which is minus 1 minus x. So we'll have y equal minus 1 minus minus 1. So y will be minus 1 so y will be minus 1 plus 1. So it will be minus 1 plus 1, which is going to be 0. So my solution, so I'm going to write it down here. So xy will be minus 1, 0. So if I check my solution, so I plug in minus 1 here, I get minus 8. This is 0, so I got minus 8. If I plug in minus 1 here, it's going to be minus 3. This is 0, it's going to be minus 3. So this is the right solution for the given system. So let's do another example. So for the second example, we are going to solve the system of equations minus 6x plus 7y equal 3 and 6x minus 7y equal minus 8. So like I say, first let me test my systems. Let me see what type of solution I will get. So I'm going to use the Isel test. So the ratio, so we have minus 6 over 6, my 7 over minus 7, 7 over minus 7. So here I will get minus 1, they are equal. Now what I do, I will check the result, which is 3 over minus 8. So minus 3 over 8 is different than minus 1, which means this is an inconsistent system, no solution. So this is a consistent system, consistent. So I forgot an S here. System, so no solution. Now, if you forgot how to use the Isel test, what you do here, you use the same process. So you pick one of the equations. For example, I pick the second one, 6x minus 7y equal minus 8. Yes, I will solve for x, for example. So I will add 7y both sides. So I got 6x equal minus 8 plus 7y. Now look at this. Look at this idea here. So 6x here, on equal minus 8 plus 7y. And on the first equations, what do we have? We have minus 6x plus 7y equal 3. You see, I have the same expression here. You see, if I square this, look, it's the same expression. This expression has a value, which is minus 8 plus 7y, which is equivalent to that expression. So what I do, instead to solve for x and substitute x here, I can just substitute 6x by this new expression. So I can put here minus, and I put 8 plus 7y plus 7y equal 3. It's the same thing if I solve for x and I plug in the x there and I simplify the 6, I will get the same answer. Just keep in mind, we try to substitute an expression by an equivalent expression. 6x is equivalent to that expression. I just substitute 6x by that new expression. So I distribute now. So you see I have linear equations, the type multiple steps. So I distribute the minus. So I got minus 8 plus 7y minus 7y. You see, this is the mistake that most of students do. What they do, they distribute the minus on the first terms. I don't do it on the second one. So when you distribute on all the terms. 3, so minus 7 cancel out. We end up 8 equals 3, which is false. This is not true. You see, when we end up with a false statement, which means the system is inconsistent, I just say no solution. Always when you end up having a false statement, this is false because I cannot have minus 8 equal 3. So that means this is false, which means that this is inconsistent. Just conclude there is no solution. For the last example, so I'm going to show you how to conclude with infinity of solutions. So I try to solve that system. Solve 12x minus 15y equal minus 63. 4x minus 5y equal minus 21. So this is my first equations. This is my second equations. So first let me use the Isel test. So 12 over 4 minus 15 over minus 5. So this is 3, this is 3. They are equal. So let me check the result. Minus 63 over minus 21. So this will give me 3 again. So the 3 ratio are equal. So this is consistent dependent system. So this is consistent dependent. So which means infinite solution. Now let's use the substitution to show that this is infinite solution. As you see in the previous example, we end up with a false statement, we say no solution. So if we end up with a true statement, it's mean infinite of solution. What is the true statement? If we end up like 2 equal 2, 4 equal 4, the number equal itself. So this is a true statement, then is infinite of solution. So let's start with any example. So let's start with the number 1. So we have 12x minus 15y equal minus 63. And I see there is a common factor here, so I can divide the whole thing by 3. So I will end up having 4x minus 5y equal minus 21. Now I pick my second equation, so we have 4x minus 5y equal minus 21, and I can solve for one of the variable if I want, but look, I notice that this expression is the same thing as that one. You see, both expressions are the same. So I don't need to solve for any of the variables. So what I do here, I just substitute this expression by its equivalent expression. So minus 21 is equivalent to that expression. So what I do, I substitute this expression by its value. So here it's become minus 21 equal minus 21. You see this is a true statement, so this is true. So at the end is a consistent dependent system, so I just say infinite of solution. So this is all about how to solve system of equation using substitution method. So I hope you understand the idea behind the lesson today, and please any comment that help me improve my way of teaching, it's really welcome. So thank you for watching the video, and